Welcome students. Today class let us say about the topic scattering of light. When sunlight enters the atmosphere of the earth, the atmosphere particles present in the atmosphere change the direction of the light. This process is known as scattering of light. What will happen? Sunlight enters the atmosphere particles means the particles change the light direction. When sunlight enters the Earth's atmosphere, the atoms and molecules of different gases present in the atmosphere refract the light in all possible directions. When the sunlight enters the Earth's atmosphere, atoms and molecules of different gases present in the atmosphere refract the light in all possible directions. Changing the direction because of only atoms and molecules. Sunlight enters the atoms and molecules, changing the direction. The interacting particle which involves the scattering of light is called scatterer. When a beam of light interacts with a constituent particle of the medium, it undergoes many kinds of scattering. Based on initial and final energy of the light beam, scattering can be classified as elastic scattering and inelastic scattering. Based on the energy wise, light beam scattering can be classified as elastic and inelastic. Elastic scattering, inelastic scattering. Energy of instant and scatter beam of light are same. E1 equal to E2. Instant and scatter beam are equal, which means there is no losses of energy in instant beam and scatter beam. Inelastic scattering. Energy of instant and scatter beam of light are different. E1 not equal to E2, which means instant beam and scatter beam are not same, which is not equal to E1 and not equal to E2, which means there is no losses, which means there is a losses of energy, which means there is a loss, there is some changes in instant and scatter beam. Inelastic scattering means compulsory there is a losses of energy, changes will occur. Elastic scattering means there is a no losses of energy. The nature and size of scatterer result in different types of scattering. They are Mie scattering, Rayleigh scattering, Tyndall scattering and Raman scattering. Based on nature and size, there are different types of scattering. They are Mie scattering, Rayleigh scattering, Tyndall scattering and Raman scattering. Keywords to remember: Mr. TR, Mr. TR, Mr. M letter, Mie scattering, R, Rayleigh scattering, TR, Tyndall scattering, first letter T and Raman scattering R. Mr. TR, different types of scattering, Mr. TR. We have two keywords to remember. Now let us see about Mie scattering. Elastic scattering, also called as a Mie scattering. The diameter of the scatterer is similar or larger than the wavelength of light. The amount of scattering is independent of the wavelength. This is the important point. Noted that independent of wavelength, amount of scattering is independent. That's why we called as a elastic scattering. There is a no losses of energy, which means it is a independent of wavelength. Mie scattering is caused by water droplets, smoke and dust. Mie scattering is mainly caused due to the particles present in the lower part of the atmosphere. Let us clearly see about the Mie scattering. Incident light and diameter of the particle which is the same or greater than or equal to wavelength. The diameter of scatter is similar or larger than the wavelength of light. Light falls on the water droplets in clouds which are equally scattered in all directions form the white appearance of cloud. This is the reason cloud appears in white color, because when sunlight enters the clouds, the cloud appears in a white color because of the equally scattered. All the colors are equally scattered in all directions. Form the white appearance of cloud. Examples of my sketching. Appearance of clouds is examples of my scattering. Clouds are white because their water droplets or ice crystals are large enough to scatter the light of the 7 wavelengths. The component of colors of white light, red, orange, yellow, green, blue, indigo and violet, which combine to produce white light. Because of the reason, the scattering of light is the which combine to produce white light, which means all colors equally scattered. So clouds appears in white color, which means independent of wavelength. Independent of wavelength, it is a elastic scattering. So incident beam and the scatter beam are equal, independent of the wavelength. Now let us see about Rayleigh sketching. Sketching of sunlight by atoms and molecules of gases in Earth's atmosphere is known as Rayleigh sketching. If the sketching of light is by atoms and molecules which have size A very less than that of the wavelength lambda of light A far less than lambda, the sketching is called Rayleigh sketching. A far less than wavelength, A far less than wavelength. Rayleigh sketching is also called as an inelastic sketching, which means there are some changes occur in incident and scatter beam. Sketching of sunlight by atoms and molecules of gases in Earth's atmosphere is known as Rayleigh sketching. The intensity of Rayleigh sketching is inversely proportional to fourth power of wavelength, which is dependent of wavelength. Incident beam of sunlight is dependent of wavelength. That's why it is called as the amount of intensity of sunlight inversely proportional to 1 power fourth power of wavelength. Intensity of sunlight 1 by fourth power of wavelength. Shorter the wavelength of light, scattering is more. Larger the wavelength of light, scattering is less. Shorter wavelength, scattering more. Larger wavelength, scattering is less. According to Rayleigh sketching, violet color, which has the shortest wavelength, gets much scattered during daytime. The next scattered color is blue, as our eyes are more sensitive blue color than violet color, and so sky appears blue color during daytime. This is the reason sky appears in blue color, which means shortest wavelength get much scattered during daytime. During sunrise and sunset, the light from sun travels a greater distance through the atmosphere. Hence, the blue light, which has shorter wavelength, is scattered away, and less scattered red light is longer wavelength managed to reach our eye. This is the reason for the reddish appearance of sky during sunrise and set. This is the reason for sunrise and sunset, the sky appears in a reddish appearance. Why? What is the reason? Shorter wavelength scattered away, and the red color is hold on in the sun. Blue scattered away, sun appears in reddish. Now let us see about Tyndall scattering. Tyndall scattering. When a beam of sunlight enters into a dusty room through a window, then its path becomes visible to us. This is because the tiny dust particles present in the air of the room scatter the beam of light. This is an example of Tyndall scattering. The scattering of visible light by colloidal particles is called the Tyndall effect. The scattering of visible light by colloidal particles. The colloidal particles, because of the colloidal particles, the light is scattered. This is called Tyndall effect. The scattering of light rays with colloidal particles in the colloidal solution is called Tyndall scattering or Tyndall effect. In pure water, we cannot see the light traveling path, but in a colloidal solution, we can see the light path. What is the reason for that? Because of the atoms and particles present in the solution, the scattered light is the path of the scattered light we can see. Next one, Raman scattering. When a parallel beam of light, monochromatic light, passes through a gas or liquids or transparent solid, a part of light rays are scattered. Monochromatic light means single colored light. When a parallel beam of monochromatic light passes through a gas or liquid or transparent solid, a part of light rays are scattered, which means there is some difference in the frequency for incident beam and scattered beam. This is called Raman scattering. The scattered light contains some additional frequencies or wavelength other than that of the incident frequency or wavelength. This is known as Raman scattering or Raman effect. Additional frequencies means changing the frequency when compared to the incident beam. Raman scattering is defined as the interaction of light ray with the particles of pure liquids or transparent solids which leads to a change in wavelength or frequency. Incident laser, incident light. Raman scatter. Energy greater than E naught means which is a Raman scattered light. Rayleigh scattering light means E equal to E naught. Raman scattered light which means E less than E naught. E greater than E naught means Raman scattered light, and then E less than E naught. The spectral lines having frequency equal to the incident ray frequency is called Rayleigh line, and the spectral lines which are having frequency other than the incident frequency are called Raman lines. There is no change in the same line means it is a Rayleigh line. Some changes the frequency means other than the incident ray frequency means which is called as a Raman line. The lines having frequencies lower than the incident frequency is called Stokes lines. The lines having frequency higher than the incident frequency are called anti-Stokes line. Stokes line and versus anti-Stokes line. Difference between the Stokes and anti-Stokes. The frequency of scattered lines is less than that of the incident line. The frequency of scattered line is more than that of the incident line. Caused by molecule at lower energy level which is more populated, caused by molecules at higher energy level which are less populated. These are more intense with high intensity of absorption. These are less intense with low intensity of absorption. At lower temperature, this takes place more frequently. At high temperature, molecules are raised to high energy state, thus energy gradually increase and become prominent. These are the difference between the Rayleigh and Raman scattering. Rayleigh scattering is a form of elastic scattering. Raman scattering is a form of inelastic. Rayleigh scattering is named after by Rayleigh John. Here Raman scattering was named after C.V. Raman. Rayleigh scattering is elastic. Here Raman scattering is inelastic. Conserve the energy does not conserve the energy. The particles involved, atoms or molecules, the particles involved are electrons. Atoms or molecules, because the frequency are changing, increasing frequency or addition of frequency or decreasing the frequency. So we are called as the electrons. Major part is electron in Raman scattering. Rayleigh scattering, the scattered photons have the same energy as the incident photons because the elastic scattering. In Raman scattering, the energy of scattered photons is either lost or increased than that of the incident photons. Rayleigh scattering does not change the chemical nature of the material in the medium through which the light passes. Raman scattering can change the chemical nature of the material in medium, especially in gases. Thank you, students.